So in this video is the second of our series on probability and statistics for 7th grade math. And I'm going to be talking about descriptive statistics, basically the measures of center and spread that we use to describe data sets. This is very important for science too, so it's a very useful video to learn about. So the first thing I want to talk about is this idea of mean. And I remember mean because it's mean to call people average, even if most people are average. Although, wait, that's not actually what averages mean. Ha! You see what I did there? Averages mean. But in all seriousness, averages are basically a description of what is the central position of the data of sorts. It's one of the measures of center. Okay, and you get that by adding up all the numbers, which is called getting the sum, all the values in your data set, and dividing by the number of values that you have. So in other words, add all the numbers and divide it by the number of numbers. So you see an example over here. We have 3 plus 9 plus 1 plus 8 plus 3 plus 6, which is all the numbers in a set. We add them up and get 30. And since there are 6 numbers in the set, we divide it by 6 and get 5 as your mean. So mean, again, is one measure of center that's gotten by the sum divided by the number of items in my data set. There's one more example here in the middle where it talks about mean as well. Moving on to the idea of median. Now, median is another measure of center, and that actually means the middle value if you put all the values from start to finish, small to largest. The median is going to be the value that's in the middle. Now, if you have an even number of values, there's not going to be a middle value. And then the median is going to be the average of the two, basically adding up the two in the middle and dividing by 2. All right. So in this example here, we have 6 values. So we have 1, 3, 3, 6, 8, and 9. So what you got to do is figure out the average of 3 and 6. So you do 3 plus 6, which is 9, divided by 2, 4.5. So in this data set, because it had 6 values, the mean is 4.5. Now, what if I didn't have the 9? So I'm going to cover up the 9 here so you can imagine that. Well, in that case, the center value would be that 3, because it will be the third value, and there'll be 2 values to its left and 2 values to its right. So see how in an odd data set, there is a center value, but on an even data set, one that has an even number of numbers, that's what I mean by odd or even data set, you will actually get the average of the 2 in the middle on an even one. Now, the last measure of center is this idea of mode. Now, mode is just the most common value. So once again, if you list the values, find the one that repeats itself. So in the example we've been tracking, that will be the 3 because it happens twice. Now, it is possible to have more than one mode, and that happens if there's more than one number that is just as frequent. So if you had the same data set, but you had another 6 here, then you would have a 3 and a 6 would both be modes. But it's also possible not to have a mode. So let's say, for example, you didn't have one of the 3s. Then there are no numbers that repeat, and therefore there is no mode. Okay? Now, all of these give you an idea of where the middle of the data is at. Now, none of these actually mean what all of the values in the data set are like. So if the average of a number is 5, right, the set is 5, that doesn't mean all the numbers are 5 or most numbers are 5 or any of that. That's not what averages mean, right? It's just something that you get statistically from adding and dividing by the number of numbers you get. So that's not really saying that everybody is like the average. It's very important to realize that, okay? The median is truly the middle number, but that does not necessarily mean that it's a better description than the mean to compare where the center of the data is. And just because a number happens many times, which is the mode, that doesn't necessarily mean that it's even close to the average, because it could be that you repeat 1 4 times, but then all the other values are really big, and so the average is going to be a really high number, even though the mode was a really low number. But it's kind of cool to look at all 3 of them together, because when all 3 agree very well, that means your data is really well centered, and there's important features about that, okay? But another important feature is to look at the data and see how spread out it is. But before we talk about that, do remember that comparing things like the medians and the means of the data allow you to kind of understand how two separate data sets compare to each other. Do note, however, that when you're doing this, highest number doesn't always mean better. So let's say you're comparing two sets of means, and one is 90 and the other one is 60. The 90 doesn't have to be a better score, right? If it was a grade, sure, that's good. But what if it was your bad cholesterol score, right? I don't know if either of those are high, actually, but my point is, there's situations where you don't want the number to be high, right? What if the 90 was the number of counts of people that you owe money to, right? So look at the context to see if what's better when you're comparing means. But certainly comparing means is one of the most easy and clearest ways that we do in statistics to compare two data sets and see how they compare to each other. Another important way to talk about this or describing data sets is looking at maximums and minimums and using them to figure out the range. The range is essentially what you get when you get the largest number minus the smallest number. If you subtract those numbers, you get the range. So it's the difference between the maximum and the minimum. Now, of course, if you know the minimum value and the range, okay, you can figure out the maximum value. So if you know the minimum value, the maximum is the minimal plus the range. And if you know the maximum value, if you subtract the range from that, you're going to get the minimal value. But the range is a way to figure out how spread out the data is. So for example, this example that we've been using, the smallest number is 1 and the biggest number is 9. So with numbers that have an average of 5 and a range of 8, what does that mean? Your range is much bigger than your average. That means the numbers are really spread out away from the average, right? So that tells you that even though mean is kind of like one of the ways to look at the center, the numbers are not really close to that center. They're spread out from that center if you compare to it because the range is bigger than the mean is. Another thing that's interesting to look at that and look at these numbers together, and something I forgot to mention, there are actually no 5s in the data set, and yet the mean is 5. So that means the average doesn't have to be anyone. No one has to be average, right, for there to be an average. So that's a very important concept. You can have an average that's biased also. If you have a lot of high numbers, right, and then you have one small number, that number can bring your average down in a way that artificially changes the value of that average, which is why it's important to not just look at averages or means, but look at the median and the mode together to figure out how your data is actually distributed. On the next video, I'm going to talk about visualizations that help us see how often numbers happen and how well your data is distributed. I'll see you guys then.